Hello and welcome back. In this video we are going to create a Hello World program using the IDE, the Integrated Developer Environment called CLion. I have CLion here on my desktop, it's already installed. I'm going to click it. I'm going to wait for that thing to launch, and then we will create our first program, the Hello World program. CLion makes it nice and easy for us. You'll see that in a moment. Okay, it's launching a program I already had here, so I'm going to just create a new project. I want to create a project called Hello World, and it's going to go on my OneDrive folder. But I'm going to change the name to Hello World 5 because I've already written a few of these. And here you always want to use the language standard C++11. So in this course, be sure you use C++11. And I'll click Create. And I want it to open in this window. If I choose a new window, you'll be left with this program in its entirety, and a whole new instance of CLion will launch. But I will launch it in this window. Here is the program. Include IOStream, int main, print out Hello World with an exclamation point. I'll be saying bang instead, because one syllable is a lot easier than 3 syllables. So we're going to print out the string Hello World bang, and then we're going to return a 0. Return of 0 means everything executed successfully. Let us run this program just to see that it runs. And our output is down here. And there it is, Hello World, and we have an exit code of 0. So let's look at this program a little more closely. CLion gave us this stub. When you create your own programs, you'll just want to remove this line and start adding your own. Up here, this is called an include file. We need to include libraries. So if you consider a regular library where you go check out books, you check out books to gain knowledge, or maybe you check out an encyclopedia to use that knowledge when you're writing a paper. It's kind of similar when we check out libraries in CLion or in C++. Whenever we see an include, it means we're going to the library. And these angular brackets mean get this book. The book happens to be IOStream. Now IOStream has a bunch of utilities that we can run that we did not have to write. So basically we're getting a whole bunch of utilities in this one IOStream package. That way we have a lot less to write in our program. One of those things we get is something called standard. That's where this cout lives. Standard lives in cout. And so does, that is, cout lives in standard. And endl lives in standard. So what we're saying here is go to the standard library and get cout. Print this string, go to the standard library, and get endl. Endl is just a carriage return or line feed. It means go to the next line. These angular brackets, the less than signs, mean send this piece of data right here to the console output. Cout stands for console output. You can equate that to the screen. So we want to send out Hello World to the screen, followed by an endl, meaning a new line. Basically, that's what we got here. We have a new line right here. We have our string Hello World. and then we have a return 0. The return from main, notice this is called a function right here, from line 3 to line 6. That is the main function. Every C++ program has one main function. And note, main lowercase is incredibly different than main with uppercase. If we try and compile this now, the program will not run. Because C++, like a lot of languages, are case sensitive, meaning it's got to be in lowercase. So the main function is the entry point when we execute a program. So after we compile, we're going to start executing the lines. In this case, there's only one line where we print this output statement, and then we return. In this case, we are returning to the operating system, and we're passing a 0 to the operating system. 0 just means success. And notice we have our function called main. This int in front of it has to be the same quote type of data that we're passing back. 0 is an integer. That's what int stands for. So we're passing back a 0, which is an integer, to the operating system. Let's run this one more time. Now, the curly braces here have a significance. The curly brace says I'm starting my main program here, and I'm ending my main program at line 6. Notice they're balanced. Notice they're highlighted too. The IDE is telling me where the start brace, curly brace, is that matches this end curly brace. So that gives you some help when you're debugging. Now, this is the main program. This is all there is to Hello World. But let's modify this a little. I just want to get into a little bit about debugging so you can see the power of these IDEs. But first, I did forget something. We have a shortcut. Everyone likes to be as efficient as possible. C++ gives us a lot of ways to be efficient. Coding in general gives us a lot of ways to be efficient. If we use the phrase using namespace, and notice how the IDE, it's kind of guessing at what I want. Well, I want to say namespace, so I can double click that, or I can just hit return here, hit the enter key, and standard. What this does is this gives me a shortcut. So anytime I'm using something in standard, which is basically cout another input routine called cin and endl. Basically, we no longer have to include these standards, because when I use the namespace of standard, it's allowing me the shortcut. Let's run this one more time. And go. And notice it ran fine with no errors. And also notice these semicolons here, they are important. They are a statement terminator. The first line does not have a semicolon because this is called a preprocessor directive. Preprocessor directives begin with the pound sign. So this is giving instructions to the C++ compiler. Now, the C++ program starts here on line 3 and goes to line 8. So most lines require a semicolon. So we use namespace standard, semicolon, int main. We are defining what's known as a function here. And every function is going to have a curly brace and an end curly brace to define the contents of that function. So this function has 2 lines in it. Then we print out the string hello world followed by a character return, and we need our semicolon. See, if we forget our semicolon here, we're going to get a red squiggly there. Anytime you see a red squiggly, it means there's an error. If we run, it says, hey, I don't know what this is because we never completed our last statement. So if we click on this error, and when you're debugging, always start with the first error that's listed. So you go top down, because errors can cascade. An error that's diagnosed up here can cause a lot of the errors below it. So I'm going to click this. It takes me to the line that it thinks the error is. Well, I know the error is right here because we need that semicolon. Okay, now let's delve a little deeper into programming. Don't worry about what I'm doing here. Just understand that it works. I'm going to create an integer. I'm going to call it num. Int num. And I'm going to set it to a value of 5. And it's a statement, so I need a semicolon after it. And I'm going to create another integer called result. I'm going to set it to 0. What I'm doing here is creating what's called variables and initializing them. So num is set to 5 and result is set to 0. Now we're going to define result equals num times 12. And I'm going to add another st out. Num equals result and L. Okay, let's run this right now. We'll just run it to see how it works. And of course 5 and 12 is 60, so we expect the num equals 60, but I made a little typo here. I'm going to call this result. Result equals 60. Let's run that one more time to see why I'm making one change and running it over again. Because anytime you make a change, you probably should compile it and run it to make sure your program still works. If you make 3, 4, 5, or a dozen changes after your program was sort of working, you don't know where that problem occurred. It could be with your first edit or your 7th edit. So you always want to get in the habit of making 1 or 2 changes and recompile. But anyway, we see everything worked. Now, let's say we had an error in our program somewhere, and let's say for some reason we were getting 72 output. So what I would do is I'd set a breakpoint. Breakpoints are a pause in execution, meaning the compiler, the code, comes down here and it sees this main function. And it says, okay, I'm going to execute the first line, the second line, third, fourth, fifth, sixth, and exit. Well, my breakpoint says execute the first 2 lines and stop right there before I execute the statement on line 8. So this gives us a view of the internal state of the machine. Now breakpoints do nothing when we just hit run. We got to hit this little bug. That's why they call it debugging. Takes a little longer, but notice the blue line here. It's saying where I am in the code. I am about to execute line 8. In this window with our variables, it's telling us what our variables are. Num currently has the value of 5, and result currently has the value of 0. And it also tells you they're integers. Note, they're also displayed up here. So let's say you had an error here. If you want to continue your program but only line by line, we press this button here. This is called step over. This goes to the next line, and we can see now result actually changed to 60. And to give you a little clue what changed, it highlights result. So we could step over and step over to the end of the program, and then here is our debug window. Well, if we look at our console, it says result equals 60, hello world. So we're not at the end of the program yet. You could tell because we have this little square here. To abort the debugger, you press the square. I don't want to abort, I just want to go to the end. So I'm going to step over again, and I have to do it one more time, and now I'm at the end of the program. So this gives you a little taste for debugging and tells you how to write the Hello World program.